evolution has contradicted the law of biogenesis. It's contradicted the law of kinds. Now we want to go to the laws of thermodynamics. Again, probably a big word as far as some of you are concerned. I don't understand all there is about thermodynamics. I did take 3 courses in thermodynamics. I have to admit that some I didn't understand, but some principles I do understand. The first law of thermodynamics is that matter and energy can be converted from one form to another, but cannot be destroyed. So what it tells us is that nothing is now being created. Matter and energy can be converted from one form to another, but they can't be created nor destroyed. There used to be the law of conservation of matter until Einstein realized that matter could be converted to energy. Of course, that's the basis behind the atomic bomb. That matter, in his famous formula, energy equals mass times the speed of light squared. So it has been converted now to the law of conservation of matter and energy. For example, do you remember the old flash bulbs in cameras? The bulb was clear, and then after they shot it, it was all white because the magnesium inside the bulb, the magnesium oxide, when you flashed it, that burned off and that gave the light. Well, if you waited before the flash went off, before it was cloudy white, and waited after, it would still weigh the same thing. In other words, it was converted from magnesium and oxygen to magnesium oxide, and it gave off light, but the matter and energy was conserved. And that's an observable law. But that law, which says that matter and energy is conserved, contradicts the idea that things are now being created. Really, what's happening is God is preserving what He created in the 6 days, but no longer creating anything new, with the exception of miracles. God can do miracles, but in general, it's a law of conservation of matter and energy. The second law of thermodynamics. Let me give you a little example of the second law of thermodynamics. I want you to line these golf tees up where they're all lined up the same way. Now what I want you to do is drop them on that screen there. It started out ordered. Those tees were all in order. When he dropped them, it went from order to disorder. If we did that 1,000 times, 1,000,000 times, it'd always go from order to disorder. Another thing maybe you're more familiar with is pickup sticks. Have you ever played pickup sticks? You line all those pickup sticks together, right? You drop them on the floor or a table or whatever you play it on, and they all go from order to disorder. That's what the second law of thermodynamics says. Systems left to themselves go to a condition of greater disorder or a greater degree of randomness, or in terms of statistical thermodynamics, a greater degree of probability. In other words, it is more probable for these tees to be arranged in a disordered pattern than an ordered pattern. It's more probable for the pickup sticks to be arranged in a disorder. There's only one way they can all be lined up together. Well, I guess it could be reversed, part up and down, but very few ways. But there's an infinite number of ways they could be arranged all over the place. So systems go to a greater degree of disorder, randomness, or probability. And that is observed over and over and over again. Now, if I could take just a minute without you looking here, I'm going to show you something. Here these same tees are. Anybody tell what that is? That's supposed to be a stick man. Now, did those tees arrange themselves that way by time and chance? Or were they a product of intelligence? Most of you question the intelligence part, that's for sure. But when you look at man, the ordered arrangement of man is wonderfully and fairly made. The point I'm trying to make is this did not happen by time and chance. This was created here by a designer, whether it's very sophisticated or not. Now, do you see this puzzle here? If you took a puzzle that had already been assembled, threw it out, dropped it, it'd go disorder. That's normal. You would expect that. But if you had a puzzle all broken up into pieces and you threw it up in the air, would you expect this to happen? No. Things do not go from disorder to order. They go from order to disorder. How does the theory of evolution contradict that? Evolution claims that somehow in distant past and even now, disordered things are eventually evolving into ordered life. That has never been observed scientifically. Do volcanic eruptions produce cities, streets, sewer lines, electrical lines, telephone lines? No. This is an example of explosion in Piccadilly Arsenal, but you can see this explosion, it goes complete rubble. Do earthquakes produce order? No, they produce disorder. The atomic bomb in Hiroshima, did that produce ordered buildings? Did the Oklahoma City bombing 6 years ago produce an ordered building across the street? The World Trade Center. And I want to tell you, no bomb, no explosion, no volcanic eruption would produce an ordered skyscraper. This has to be produced by design and purpose. The idea for the origin of the universe to have occurred by time and chance or by an explosion some 15 billion years ago is ridiculous from a scientific viewpoint. When did the second law of thermodynamics begin? When did things start falling apart? Everything was good. In fact, everything was very good. When he saw all the creation he had made, he said it was very good until Adam sinned. It was then that God placed the curses on the earth. The biggest curse, of course, is the curse of sin and the curse of death, because the wages of sin is death. But other difficulties, like in sorrow you shall bring forth children. That's why Marie's mother could tell us something about the pain that she endured to bring forth Marie. Thorns and thistles. And, of course, we have to work now by the sweat of our brow. Of course, worst of all is death. That's when probably the second law of thermodynamics began, is when Adam and Eve fell in the garden. Now, are there any exceptions to the second law of thermodynamics? People like to point out things like snowflakes and other crystals. If you looked under snowflake under a microscope, it's a very orderly pattern. There's no two snowflakes alike, but they're arranged in a hexagon-type pattern. You might say that's an example of disorder producing order. Let me give you an illustration that would help explain it. Have any of you ever played Chinese checkers? You know, like the game where there's the little holes in there? They're arranged in a definite pattern. If you drop marbles on just a glass like this overhead projector, marbles would go all over. But if you had a rim around those and you began kind of shaking them a little bit, would the marbles eventually arrange themselves in a pattern? Yes, they'd fall into the pattern prearranged and predetermined by the board. According to chemical theory, molecules have definite shapes. For example, water has a kind of a bent pattern. There's methane, CH4, has a tetrahedral pattern. There's different patterns. And crystals, crystal of table salt is different from a crystal of other thing. They have different shapes. The reason they have different shapes is because, according to atomic theory, the size of the ions are different. And because of the size of the ions being different, they pack in a different way. So they always will pack like in a cubic closest pattern or some other pattern. They'll pack in it because of a predetermined shape and size of the ions or the molecules involved. So that is really not a contradiction to the second law of thermodynamics. Trees grow, well, even embryo in the human or any other, in any mammal or anything that goes from an embryo to a fully developed thing. It's not disorder, it's a predetermined code that's in the original genes and original cells that are started. So really, I think the answer to are there exceptions to the second law of thermodynamics, I would say no. There are no exceptions.